Okay, today we're going to look at how to lay out a board. You're going to have to learn some program. The most popular one is a program called KiCad. I've been pronouncing it KiCad for so long, but it's K-I-C-A-D, and it's free, runs on Windows, runs on Linux. I think it runs on the Mac. I'm going to have to learn it myself. I've been using another program, but they all work very, very similar. So I'll leave that as an exercise for the student. Now, we're going to build this transistor fixture, and I'll show you how I would do it. First of all, I'm going to go and bring up my little program, which runs under Wine. It's called Sprint Layout. Works like this. Now we're working with boards that start out 150 by 100 millimeters that we're going to get from ABC-Fab. I'm going to show you that before we end this video. I'm going to cut them down to whatever size I need. Now I'm guessing, I'm going to make this one 100 by 60 millimeters. So I go over here and I say the width is going to be 100. And I'm going to say the height is going to be 60. And I get this grid that's 100 by 60. And under KiCad and any other program, you can set the grid to whatever resolution you want. Let's do this at 2.54 millimeters. 2.54 millimeters is 1/10 of an inch. That's the spacing on pins for things like NE602s and LM386s and everything. Also, I use 2.54 millimeter headers, both female and male, as connectors and everything, because I don't need, for most of my little experiments, I don't need everything to be permanent. And I can switch between power supplies and headphones and all kinds of things I'll show you through this series. Now let's go back to the schematic. Now what I do is I just lay the printed circuit boards and the components in the same order they occur on the schematic. So we're not going to do anything on the board for this other than I need a input pin, and I'm going to start and I'm going to just lay all the components in this branch here in a straight line. And I'll start it out and I'll show you. And I'm going to alternate, hope you don't get sick. I'm going to alternate between the schematic and the layout program. So here's a header. This is a 2-pin header. These are 2.54 spacing millimeters. So let me go over here and let's put it, let's start there. Now, we label the ID and then we give it a value. But Mr. Wenzel didn't do any IDs, and I'm going to speed through this thing, so I'm not going to fill this information in. So I'm going to make it not visible, and I'll say OK, and there's my input pin. That's where we're going to feed it the RF generator. Now I need 2 resistors in parallel here. Now we're using 1/4 watt, so I'm going to use 10 millimeter spacing. So I go over here and in KiCad, whatever you got, a component libraries, and I'm looking through hole resistors and standard, and let's do a 10 millimeter. So that's what it looks like. Now in the schematic, the resistor is horizontal. So I'll just rotate it 90 degrees, left click on it and draw it into the PCB board area, and I'll put it right here. I'm not interested in labeling it, so there it is. Now what happens now is I'm going to put a trace from the input pin to this lead of the resistor. Okay, so I got the 560. Let's put the 100 ohm in there. Whoops. I'll put it just below it, and I'll put it spaced 5 millimeters, 5.08. On the spacing, you're going to have to learn this. What I would recommend is get one of the little, I call them vector boards. They're little boards that have 2.54 millimeter spacing on holes, and it looks like a grid. And take some components and look at how they would fit between the holes. So now I've got 560, 100. Now I've got a 27 ohm resistor. Now we'll just put it vertical like it shows in the schematic. So I rotate this 90 degrees, and it's lined up with the pin, the input pin here. Well, I'm going to put the input pin here. So all this lines up. So I'll do that. Next comes this 1 microfarad capacitor. But remember, in the description, he put 2 capacitors in there. He put the 1 microfarad and a 100 nano. So I'm going to need 2 caps, and I'm going to need mono. I have my own symbol for the mono. So here we go. I'll use that. It's horizontal. So I'll put it there, and I'll set it right there. No labels. I got another one. Goes right there. Okay. Now this is 5 millimeters. That's plenty of space. And you just go component by component. Let's put in another resistor. Now, one of the things I can do is I can go over here and copy this thing and then do a paste and put it right there. Let's put it close. Okay. Then I need a horizontal resistor. Put it there. Now I need the device under test, which is a transistor. So I go over here and I have a little one that I've got of my own, a TO92, and that's what it looks like. And the output from this resistor goes to the base, so I'll line it up with the center pin. This goes collector, base, emitter for a typical 2N3904, and you just go component by component and lay it out. Now let me show you what I did. I'm going to go and do open, and I've got here it is. I've got one laid out here. Save changes. This means, do I want to save that one? I'm going to put no, because that was just scratch. And this is what my layout looks like with no labels. Now, so you can see here's the input in, and I'm going to label all this, and I'll put this image plus the thing that you can print off and make a board. Here's the two, what was it, 560 and 100, 560 and 100, the 27, the 0.1, etc. Everything's on there. One of the things that I want to experiment with is that I'm going to change the voltages here. So I want to know what the current is, and that's it. I need to measure the voltage here, divide it by 100, and that'll give me the current. I want to measure the voltage across the transistor from collector to emitter. So here, if I want to measure the voltage from the collector to emitter, how would you do it here? Well, it's going to be a little bit difficult. But what I can do is I can put in some test points here and here. Just connect the collector to this test point. I'll put one of the pins out of a 2.54 header here. So I got this sharp pointy thing up on the top of the board, which I can hurt myself with. One here. If I measure this voltage, that'll give me the current through the 100 ohm. If I measure this one and subtract this one, that'll give me my collector to emitter voltage. And then we're going to go back to some data sheets and see with different measurements how the transition frequency varies due to bias and whatever on the transistor. Continue on here. So here's where my RF comes in. Here's my calibrate, and this is my out, okay? And this is my power supply. Now, this is our first project, so I'm going to label this. Now, we're going to print this, and you're going to want to know what board is, so I'm going to go to the bottom layer. Always do all your work in the bottom layer of a 2-layer board. I'm going to put some text. Let's make the height like 1.5 millimeters, and let's call this, now this is, of course it's called ACES, and this is project number 1, so we'll do ACES 001. Let's do bold so that when I etch the board, I don't get part of it flaking off. Horizontal, and so here you see it on the reversed, because look, we're looking at the top of the board. Flip it over, then the letters would be readable. Let's put it somewhere. Where do you want it? You want it down here? Let's put it right there, and then I'll right click. Whoops, I didn't right click. I killed it. I'm sorry. Okay, do a left click, and now when I etch the board, this, you'll have blank areas, and this will be, maybe that's not big enough. Well, I can click on this. Whoops, let me click on this. I go over here and change the height. Let's make it 2 millimeters. Okay, makes it large. Let's date it. We're going to make this 2 millimeters. Let's date it. What's today? Year 2025, September 15. Okay. I did it again. It's a visitor effect. Let me put it down here. So now I'm ready to, whoops, I really don't want it there. I just thought of something. So let me just move it over here. One of the things you're going to go with your scope or whatever, measure the standard point here, and then measure this, and then change your frequency on your generator until this matches that. Let me check my time. 13 minutes. Okay, having fun. What I want to do is, I have an RF probe, and you should look in chapters 2 and 3 of the ARRL handbook and look at the appendix of EMRFD and look at how to build an RF probe. What I want to do is I want to use a RF probe, but I don't want to move it back and forth. So what I'm going to do is I'm going to put an output pin, 2 pins. Let me put it horizontal, and I'm going to put it down here to connect my RF probe to. And then I need a switch. Now let's assume that it'll fit in a 3-pin thing here. Let me put it, let me move it, okay. Say this is a switch that's a single pole, single throw. and I'm going to feed the output from one of these two to the output of this pin here. So let me do a track, and I've set my tracks at up 0.5 millimeter, made them fairly large to start out, and let me route this. So I'm going to go from here, let me go down, let me go down, whoops, that's going to be, okay, this is going to be too close. All right, let me move it. I've got to get this done in a hurry. Okay, pad, route from here, down, oh, let me go just down, across. Which pin do you want it on? Let's do it on the right one. Okay, now take the output from the calibrate, or cal, and let's go route it. I'll route this by hand, go out here, get away from there. Oh, let me undo that, because what I want to do is I want to go and increase the resolution here so I can get closer to the center of this resistor. So here we go. Go output, this is cal. Go over here, that looks good. Let me go further out over here. All right, then go there, go down here, go across here, go across here. Okay, so the switch is in one position, then the output from here will go to here. And I want the out also to be switchable. So let's go, this is an out, so let's go here, down to here, get away from the print there, go across here, and okay, so this is a little switch. I'll go and label all these. So I'm ready. Now let me turn off the silk screen, because we're not printing silk screen. This is what the board will look like. But I have one more problem. You see all these ground points here? These are what, 2 caps here. If I move in close, these are not grounded, so I want to make these thermal pads. Now, a thermal pad is a pad with 4 vanes that connect the pad to ground. The reason you do that is if this thing is solid to the ground, it's going to take a lot of heat on your soldering iron. So this allows you to do soldering faster. So I need to take all the pads that go to ground and fix them. Okay, 18 minutes. I'm sorry, 20 minutes. Let me go, and what I'll do is everything like this needs to be a ground, so I make it a thermal pad. This needs to be a ground, I make it a thermal pad. Let me go and do all those and come back. Okay, I went and made everything that's supposed to be ground. Now, I need you to just check this. Let me enlarge this. Everything that's supposed to go to ground has a little pad here. And I haven't labeled anything, so let me come back tomorrow and finish this. What I'm going to do is I can take and go print. And what happens, this sets up a PDF. So let me put this down in the middle. So this will be my board. I don't want to do the top layer, and I don't want to do the silk screen. So this is what I'm going to print off. Let's see, I'll show you tomorrow. So on the setup, I usually go to a printer, but I can I'll send this to a PDF. So do a OK, and it sent it to a printer, which is, whoops, CD, PDF, LS, and today is, what is this? This VXO. Whoops, where's my Did I label it? Oh, I didn't print it. There it is. So if I do a look at it, this is what it looks like, and this is how it'll come out on the printer. So we'll do that tomorrow, and I'll fill in anything that I left out. I'm sorry this took so long, but we're off and running. Thank you, and we'll just get this thing done tomorrow.